Studio Professor Dr Dolphy Gilpin. Good morning, and we're continuing with our study of chemistry. Now, my first serious study of chemistry, of a long-term process, a 5-year process, was to study the first 20 elements, and that is in reference to Cambridge University exam, Cambridge British. The first 20 elements was focused upon, and plus some other random elements like everyday elements that we meet upon, like that is out of the range of the first 20 consecutive elements. Like iron is out of the range, but it was studied. Lead, copper is also out of the range, and iodine, chlorine. Well, chlorine is within the range. The chlorine is about 17, atomic number 17, and there are others. I have to mention like uranium. That's out of the range, but that was mentioned just for reference. Sodium is within the range because sodium has atomic number 11. Potassium is 19. Calcium is 20. So there are others like the primary metals, the fundamental metals, copper, iron, zinc is also out of the range of the first 20. And there are other gases, like noble gases. They were studied, and some of them are out of the range of the first 20, and so on. But here I am focusing upon the last 20. The beginning of the study of chemistry, it was the first 20. Here I am focusing upon the last 20 elements. And so if you look at, say, from 100, (101) was unmium, UNU 101, that is mendelevium, with electronic configuration of radon 5F13 7S2. And unyl bininium, UNB 102, and that is nobelium, which has atomic number 102, atomic mass 259, nobelium, and a electronic configuration of Rn 5F14 7S2. We're focused upon the last 20. Elements of the periodic table. And these two, 101, 102, 103 is up the top here, unyl trillium, UNT 103, atomic mass 262, that's lawrencium, and that has a electric configuration of Rn 5F14 6D1 7S2. So we have done 101, 102, and 103, unyl trillium, and 104, unyl quadrium, which is in the IUPAC modern would be UNQ 114. It's 114, 261, I believe. And that's rutherfordium as an electronic configuration of 5, 6D2, 7S2. 6D2, 7S2. 5F14. And if we go to 105, we'll have unyl pentium, UNP 105. That is dubium with an atomic mass of 262, Rn 5F14 6D3 7S2 electronic configuration. We are focusing on the last 20 elements of the periodic table in relation to studying the first 20 back there in 1974 over a 5-year process for the Cambridge. I noticed that the properties of these elements have not changed. There might be additional infinitesimal knowledge gained upon some, but for the most part, the properties back there in 1974 are still the properties of the elements in 2024. Also, the atomic numbers does not change, neither the atomic mass. They are still the same. So that's it. We have made some modern discovery since then, since 1974. We have made some additional elements to the periodic table, and we're going to be mentioning some of them in the modern IUPAC form. 106, unyl axiom, UNH. 106, atomic number 266, symbol SG, C Borgium, electronic configuration in the form of the noble gas would be Rn 5F14 64 7S2. And we're going to mention one more, then we take a break and return. So we have 107 unyl septium, UNS 107, atomic number 264, atomic mass 264 rather, and atomic number 107, symbol BH, borium, electronic configuration Rn, which is radon 5F14 6D5 7S2. And so I'll take a break here, and before I take a break, let's try to give a magnified view. So we had looked at 101 unyl ulmium, UNU 101 mendelevium, atomic number 258, and 101 mendelevium, and that was its electronic configuration. Now we look at 102 unyl binium, UNB 102, nobelium 102 259 atomic mass, and Rn 5F14 7S2. And then we turn to 103, which was unyl trillium, UNT 103, UNT 262 atomic mass, and that's LR lawrencium. 104, 105, 106, and 107. Let's just highlight 105, 106, seaborgium, borium, and that's where we will take our break and continue.